Okay, so new type of problem today. We are going to take a polynomial, rational polynomial such as this one, and write it as a sum of partial fractions. It's called a partial fraction decomposition, and it fits in with what we're doing because sometimes you might need to take an infinite sum of some series, and you don't know how to do that. So maybe if you can split it up into the sum of two separate terms, maybe, just maybe, you can split it up into two sums that you do know how to find the infinite series of, the infinite sum, and then you can answer it that way. Or maybe it would turn out to be a harmonic series where things beautifully and magically cancel each other out. Who knows? But in order to figure out if something like that is going to happen, we need to do what's called a partial fraction decomposition. So let's go ahead and do that. So go ahead and jot this problem down. 3x minus 8 times x squared, 3x minus 8 over the quadratic x squared minus 4x minus 5. And we will get started. So the first thing we want to do is we want to factor the denominator. So let's leave the numerator as it is, and let's factor the denominator. That is a nice quick factor into two linear terms. We're going to get x minus 5 and x plus 1. If you don't believe me, check it yourself, but it totally works out. And now our goal is to split that up, like I said, into a partial sum, which means essentially one fraction plus another fraction, but we're dealing with polynomials here. So in this case, we're going to split it up as follows. We're going to split it up into the two factors for each of our denominators. So we're going to get x minus 5 is going to be the denominator of our first fraction, and then we're going to do plus x plus 1 is the denominator of our second partial fraction. And we don't know what the numerators are for either of these, so we're going to give them generic variables a and b. Now if you focus on this bit of our equation so far, we have 3x minus 8 over the quadratic x minus 5 times x plus 1. And we have that equal to this set of partial fractions. Now we need to actually figure out what the numerators are for those two fractions. Now notice we do have an equal sign there, so we're dealing with an equation. So what I want to do is I want to take this equation and I want to get rid of my denominators. I want to essentially make it so I'm no longer dealing with fractions. Now to do that, I'm going to multiply by the denominator of the left side. So that whole quantity, x minus 5 times x plus 1, I'm going to multiply by that on both sides of the equal sign. Do that and it'll go something like this. Notice on the left side of the equal sign, we have the same thing in the numerator and the denominator, so that's going to cancel out, and we're going to get 3x minus 8 on the left. And on the right, notice we're going to be distributing that product, that quadratic, into both of those fractions. Well, if you look at just the first fraction, a over x minus 5, multiply that by that quantity right there, and your x minus 5s are going to cancel out. So you're going to be left with a times x plus 1 for that first fraction, and then plus, same idea here with b. Look at your denominator there, x plus 1, well that's going to cancel with that x plus 1 right there, and we're going to be left with, sorry, keep the same colors, you're going to be left with b times x minus 5. Neat-o bonito. Go ahead and catch your breath, make sure you are all caught up. When you're ready, move on to the next bit. That next bit is going to be, what I want you to do is I want you to distribute that A and that B into those two quantities, x plus 1 and x minus 5. So go ahead and distribute those terms in, and then try to factor the right side of your equation into some quantity times x plus some quantity. So you'll get a linear expression, essentially. Give that a go. Let's go 3 minutes and then hit play again. So pause the video now.
You don't want that whole thing.
Alright, so let's go ahead and factor those that a and b in, and then try to factor an x out. And let's see how it goes. So we're still going to have the same junk to the left, 3x minus 8, but then we're going to get equals ax plus a plus bx minus 5b. Let's line our terms up so we can get 3x minus 8 equals ax plus bx plus a minus 5b. Okie dokie. Now, like I said, we're going to have a x term and a constant term, so let's factor that x out. We're going to get 3x minus 8 equals, factor that x out of those terms, ax plus bx, and you will get, in parentheses, a plus b times the quantity x, plus our constant term, a minus 5b. Neato bonito. I think I just said that before. Well, we have a linear expression equals a linear expression, and so we're essentially going to get a system of equations. For this equation to be true, we're going to get the first equation, 3 equals a plus b, from those coefficients right there. And we're going to get the second equation, negative 8, equals a minus 5b, our constant term. So we get an equation from our x term and an equation from our constant term. And now, this ain't nothing but an old system of equations. So write yourself a matrix and solve that sucker on the calculator. Do that, and remember, so enter your matrix, do your reduced row echelon form of that matrix. Don't let that confuse you. So do that on your calculator, or solve this system by hands if you are afraid of technology and want to make it more difficult. But either way, do that, and you will get some really, really ugly answer. And you're probably going to look at it and be like, holy crap, there's no way that's right. But then use the fraction feature on your calculator. So go math, frac, and then do that to your answer. And you will get the really nice, pretty fractions that tell you A is actually 7 over 6, and B is actually 11 over 6. So ugly, but actually not so bad. Okay, well, let's finish this up. The whole point of this was going all the way back up to the top where we started. We found the coefficients for this partial decomposition right there. We found A and B. So now we can write this expression, and I'm going to rewrite it all below where it's clean. Jump back to the beginning. Our whole thing was we wanted to find those coefficients A and B to write this quantity, 3x minus 8, over x minus 5 times x plus 1, as a sum of two fractions. So we can quite literally write this as 7/6 over x minus 5 plus 11/6 over x plus 1. And I know that looks hideous, and it looks like that should not be mathematically acceptable, but that is actually our goal. Now, your task is to take this partial fraction decomposition, 7/6 over x minus 5 plus 11/6 over x plus 1. And I want you to find a common denominator, add those two fractions together, and prove to yourself that you do, in fact, get that quantity, 3x minus 8 over x minus 5 times x plus 1, when you simplify everything down and reduce it all. That is your goal. Go forth and do that. You have 5 minutes to do that, and then we are going on to the next video. Good luck. You should be able to get it. It's ugly, but it gets nice.